Welcome back to part 2 of trying to fix the original Williams arcade machine Defender. We found a number of problems in part 1, but there's going to be a lot more that we find in part 2. So if you haven't seen part 1, I suggest you check that part out first, and let's get on with it.
I've brought the power supply back over to the blue mat here because the connectors that I've ordered have arrived. So I'm going to replace these ones that I've got round pins with the ones that I've got square pins. I've just finished doing the one on the transformer on the actual cabinet, and I've also got a new IC to replace this one here for the 5V side of things. I'm still not sure if this transistor's okay, but we'll check that as well. And I've also got this trimmer pot here. And what I'm going to do is replace this end resistor here with this little trimmer pot, and then that gives you a little bit of adjustment over the 5V supply, so we can either take it up a little bit if need be for to supply the logic board, because it was on 4.9 and it's supposed to be about 5.1. So let's see if we can check this transistor here. Base is the center one. Let's just see if we get any shorts between emitter and collector. I'll just go to diode check. Now there should be a diode across one way. That might be capacitors we're measuring there. I'm not getting any shorts, so I think that transistor's okay. So what we'll do is we'll change the chip, and I've just treated myself to a new tool. I've got one of these desoldering guns now, so I'm going to switch that on and give that a go with this IC here, because I have got a lot of RAM chips that I need to replace as well. I'm just going to replace the sockets, so that's why I thought I'd invest in one of these. I think the desoldering gun should be warmed up now. I'll just move the meter out of the way. Now I've always found that soldering something first makes it easier to desolder. So I'm going to put a bit of fresh solder on there first, I think. I'm not sure if that's working right. I think I'm going to try some low melt on this. Put a bit of flux on first. I think it's got it soldered from the top as well. I'm just going to grab my tweezers. And use some solder wick to clean that up. Use a bit of IPA. So I might have one pad that's got some solder in there maybe. I'm just going to check a couple of other components while I'm here. Let's just check this diode. Yeah, that looks fine. Right, I'll get the chip socket in. I think that'll do for that. I'll just give it a clean up. Excellent. That's that bit done. Might as well pop the new chip in. Need to solder that resistor back on. And then we need to put the new pot just in here. Right, I'm going to start desoldering these connectors next, I think. So I've just finished changing this connector here, and I've just noticed on this connector here, you can actually see where this pin has had a bad connection and it's been getting hot. So it's probably a wise move to be changing these. So I'm going to continue changing the rest of them, and then we'll continue once I've changed them all. I've just finished replacing all of the connectors, and I've just removed the resistor that was originally here. And what I've done with this is I've bent the middle leg over to join onto that one, and the other leg are bent like that, so then hopefully that should fit in the place where the original resistor was. So I need to solder these two legs together first, so I'm just going to do that now. Just like that. And hopefully that should just fit in there like that, and just solder the legs up on the bottom. Right, I'll just finish cleaning this up and then that should be it for that. I don't know if he wants us to change the capacitors. I might ask him, see if he wants us to do a recap on this or not. But on all the caps I've tested, they all seem fine, so I don't know whether it's worth doing or not. Right, let's see if we can get this PIA chip out then. I'm going to use my new desoldering gun thing on this. We'll see how that works out. I don't think that looks too bad. I think there might be a couple of them that might still have a bit solder. Yeah, I think that's pretty much it. Let's have a look. Yeah. The only thing is, there's a lot of them soldered still on the other side of the board. I might be just getting away with that. I'm not going to get away with that one though. There's one soldered right at the end here. So I might have to do that one with the iron or something. I think there's a one just a bit further back as well. I can't quite get in for the ribbon cable either. Right, it's out. I don't think we've damaged any pads, so that's good. Right, let's see if I can clean these holes and that up. I think they're mostly alright. I think it might just be one or two. Right, that doesn't look too bad. Let's see, we don't seem to have damaged any pads. It's the old PIA chip there. And I've just noticed there's actually something written on the back of this board. I don't know what that says, but yeah, I just noticed that. So, got a new chip socket. So let's get this PIA out of the way. I haven't got the new PIAs yet, but they're on their way. So when they come, we shall fit those. So I'll get this socket soldered up. Just going to make sure that it's flat against the board. I'll just do one leg at this side first. One side done. That's the other side done. Let's put some IP on that and give it a clean up. And it's almost like we were never here. Excellent. Another little job done. Well, this is something interesting. I was just about to start on the main CPU board here. And I noticed it's got the 3 caps here, and I thought, well, you know, should I just change those? I've got some caps here. So anyway, I took the one out of the I/O board, and we'll just measure it with the ESR 70 Gold here. And this is 100 microfarad at 25 volt. And we'll get 125 microfarads at 0.41 on the ESR. So I'll just grab a brand new capacitor that I've got here, which is the same value. And it's actually worse than the one I'm taking out. It's got a higher ESR, and it hasn't got as much capacitance. so I think I might put the old one back in, because it seems a bit pointless putting a one in that's worse. It just doesn't seem to make sense to me, even though I know it's a new one. But let's see, we'll just try that again. Yeah, more capacitance and less ESR. And I've noticed that these capacitors as well, they don't have a vent on them, and they're sort of more sealed at the bottom. It's like, it's got like a varnish or lacquer at the bottom. Whereas like modern capacitors, they've got like the vent at the top and they've just got like a rubber bung at the bottom. So I'm going to pop this one back in, I think. I just thought that was a little bit interesting. So there's a fair bit of work to do on this board. This battery holder needs to be replaced because it's all corroded at the bottom here. So what I've got for that is one of these CR2450 battery holders, which I'm going to mount across here and then put a little patch wire from here to ground on the back of it. Sorry, from here to ground. I've got all the RAM chips holders to change. There's an IC to come out here and a socket to go in. And I've got these 3 connectors here to change, and I've got some ones that I've already prepared. And I also need to do a little modification on the back of the board, because the new RAM I'm putting in only works on 5 volts. There's one of these pins got to be pulled up to 5 volts. That's an address pin that's not on the other RAM chips. So an easy way of doing that is to cut the 12 volt supply wire here, so 12 volts isn't going to it, and wire it to 5 volts, so then the pin gets pulled high by the 5 volt supply. And then the RAM should work as intended. So I think I'll swap the connectors and the battery holder first, and then I'll do the torturous part of the RAM chips, I think.
A few moments later.
That's the old sockets removed. So let's get the new ones in place and then we'll solder them up. Let's get these soldered up there. And that's one little job out of the way. I've got to turn my iron up a fair bit to compensate for the heat dissipation on the ground plane here. Right, is that done? Now to get these battery holders off, you can see the corrosion on them. I'll just zoom down a little bit down there. So you can see they're all not in the best condition. Might even be some parts of them missing, judging by this. Because there's like a bit of a flat disc on here and then looks like an insulator, where these ones haven't, so perhaps it's even rotted off. It needs changed anyway, so we'll get that out. Well, that actually came out easier than I was expecting. That's why I thought I'd do it off camera. I was expecting it to be a bit of a job, but it actually came out fairly easily. You can see the corrosion on these terminals here now. So what I've got to replace that is this 2450. So one of these. And the way this is going to work is that's the negative, this here, and this is the positive. So it's going to go on like that. And if we just flip this board over, you can see the positive runs down here and it goes off to the board to the CMOS settings IC, which is this one here. And then the negative normally goes through the other cells and then to ground here. So what we'll have to do is, this track here, we'll either take a little bit of the solder mask off here and just put a little link from there to there, which I think is probably going to be the neatest way of doing it. Or we could solder a wire from here to here, which would be another way of doing it. Might actually solder a wire across the front of the board, and then we're not actually altering the board at all, and it keeps it original. So I'll solder this up like so, and then I'll see if I've got a bit of solid wire or something that I can go across from there to there. Right, back in a moment. So what I'm thinking is just something a bit like this. I've just cleared these two holes here, and we'll just solder that in like that, and just snip the legs off on the other side. I'll snip the excess off rather. Something like that. Let's put a little blob of solder on that just to make it a little bit tidier. So that should do for that little job. So we've got this IC to remove next, so I might do that. I'm dreading doing this bit, so I'm trying to do all the other bits of jobs first. So to that IC there. Right, I'm going to switch my new solder sucker thing on again then. Just going to put some fresh solder on it first. Look at that top hole wants to clear very well. I wonder if I need to have the temperature turned up on this or something. I think that might be what the problem is. Still not clear on some of those though. Yeah, I'm not happy about thinking that one out. I think I might put some low melt on this. Some flux on it first. Just I don't want to damage the board, that's all. I hope this is the right trip that I'm taking out. I'm just going to keep that corner one up because I don't think that's quite clear. That's a bit better. Right, get that soldered up. Might as well clean these up as well, so that one hasn't been done. Right, so that's ready for the new IC when it comes. Another modification I need to make is just a slight alteration to this power input plug here. And I've already removed the pins for the -5 and the 12 volt regulator. I've snipped those off, so they are no longer there now. And the reason for that is because the new RAM chips I'm putting in don't need these two voltages. However, they do need a 5 volt on one of the pins that was previously used by the 12 volt and the 5 volt. So how I'm going to do that, I'll just flip the board over. So bearing in mind this diagram is going to be the opposite way around now. So we've got -5, 12 volt unregulated, and that's used for reset. Then we've got +5 here, and then we've got the next pin down, which is actually no connect, but it's actually still connected to +5. So both these two pins here are +5. I'll just zoom down a little bit. So both of these pins here are actually +5, and then the next one is 12 volts, which goes along here, and then it goes off to the RAM chips. But I need to have 5 volts on that one. So what I can do, I can just put a blob of solder between those two pins there, and that's it. So that's what I'm going to do. So if I just join those two pins together there with a blob of solder, like so, and that should be it. And there's no chance of getting 12 volts into the board or -5 volts accidentally because we've cut those pins off. I'll show you where that line goes. It goes down here, and then to that chip there. Another way of doing it would have been to join those two pins with a wire link. So I hope that makes sense.
One eternity later.
Right, we've got one row of sockets in place. Just need to solder them all up now. I've just got them one leg just on each chip soldered for now. So, let's see how this goes. Whew. Right, that's one row done. I don't know if I'm going to do the other two rows. The actual pins that I took out of the sockets actually don't seem that bad. It's like if I just pull one of these sockets apart here. That's the actual pins there. They don't actually look too bad. I know they're only single leaf, but they don't look corroded or anything. It was just recommended to change all of the sockets on this, but I might just leave the other two rows because they look fine, to be quite honest with you. Right, clean this flux off. I put a little bit more solder on that one there. Yeah, I think that looks fine. I've fitted all the new RAM, so the only thing that I'm waiting for at the moment is this IC here and two PIA chips, because I'm going to change the one on the ROM board and we need the one for the IO board. So once those arrive, we'll be able to test it and see where we're at now, see if it works or see if it's got more problems. Remember this mess? Well, what I'm thinking about doing with this is possibly using some of this stiff tinned wire here and following where the tracks used to be and then putting some PCB mask over it. I mean, this is functional, it's just a bit of a mess, that's all. So I'm going to have a go at that, and then once I get a bit further on, we'll continue with the video and we'll see how I'm getting on. Right, I've just finished repairing this tube base. Let's just have a look. So that's what it looks like now. So I think that looks a lot neater. I mean, what do you think? Leave it in the comments below. So there's the monitor board back in situ now, and that looks a lot better, doesn't it? Instead of all those horrible purple wires hanging about. While I'm waiting for the rest of the parts to arrive, I thought I'd check to see if the power supply is actually working. So I'm just going to power it on now. And we do have a light on the 5-volt one, so we'll just go into volts. Now this will probably need adjusted. So let's see what we've got at the moment. And we've got 3.6. So let's see if I can get the probes just on here somewhere. And we should be able to adjust this now. A little bit too much. So I want that to be around about just over 5.1. So something like that. So excellent. So that's worked spot on. Right, onward and upward. One of the other things I've done is replaced the wiring from the power supply here up to the logic board, because the wire they'd used wasn't really thick enough and we were getting a voltage drop from the power supply to the main board. So when I measured the voltage on the main board, it was actually a little bit down from what it was on the power supply. So replacing these wires with thicker gauge wires solved that. Well, the new logic chip arrived, so I've fitted it there. I've sorted out the power supply. I'm still waiting for the PIA chip for the IO board. So let's just switch it on and see what it does now, see if it does anything different. Let's see if we get ROM 10 failure still. Oh, we've got a different sequence of lights there now. I'll have to have a look in the manual to see what those are. Let's have a look to see what we've got on the screen. Oh, we've got text. Initial tests indicate RAM failure. Let's just try some of the buttons here, see if we can do anything.
All ROMs okay. Well, that's a bit of progress. RAM test, let's just see what that says. And it says RAM failure, RAM 11. So I think that's chip 1, bank 1. So I'm going to try swapping that, and we'll see if that does anything. But I'm not sure if it will. I'm wondering if it's some kind of decoder issue or something, because it seems strange that the first RAM chip's faulty. I mean, it could be, but we'll find out. I've just pressed the button again there, and it says CMOS RAM failure. The test must be entered with the coin door open. Well, the coin door is open, but there's supposed to be a switch here, and I've got a few wires here that are soldered together, so whether or not those are supposed to be the ones for the coin door or not, I'm not sure. But also where that switch is supposed to go, this plug doesn't reach because it's supposed to go down there. So I think it's going to need a bit more work. So we've got two problems left on this. One of them is the CMOS RAM problem, so we're going to have a look at that bit first. So we've got a signal comes in from the coin door switch. It goes up this trace here, and it goes along and then goes into pin 1 of this 4071 OR gate. And we've also got signals coming from the MPU, which come through here as well, and they go to the read write pin on this chip, so it enables you to read and write from the chip. Now I'll go over the scope and we'll have a look at the board, and I'll show you what I've discovered. So I've got the machine booted up, and we'll just have a look at the third pin down on here, which is pin 20, which is the read write pin. I'll just reset the unit, and if we notice, the read write pin is always low, never changes. Nothing at all on that. So this goes back to pin 3 of this IC here. So let's have a look at that one. As you can see, nothing there. So the inputs to this chip are actually pin 1 and 2. So if we go on pin 1, we can see we've got a signal there, and if we go to pin 2, that's actually this door switch here. So if I press this door switch, we can see we've got a signal going to it now, and if I release it, you can see the signal goes, but we've got nothing on the output of this chip, just a flat line. So that chip there needs to be replaced, this OR gate, so I'm going to have to order one of those because that's definitely faulty, and that's probably the reason why the RAM chip here isn't working. So that's one problem. So the next problem that we've got to look at is the RAM. So if I go down to the RAM here, and it's not the RAM chips because there's no corruption on the display. What I'll do is I'll pull the first RAM chip that it's saying faulty, and we'll have a look at the display, and I'll show you exactly what I mean by that. What I'm going to do, I'm just going to remove this chip here, which is the one that it says is faulty. Now I've already replaced this, but I don't think it's not the chip that's faulty, and I'll show you why. Because I'm going to switch it on, and then we'll have a look at the screen, and you'll see the difference that it's made. Right, I'm just going to switch the machine on, and we'll go around the front, and I'll show you the screen. Just wait for it to come on. And as you can see, we've now got all of these vertical lines because the RAM chip's missing. So that got me thinking, the RAM itself isn't faulty because we haven't got any screen corruption. The CPU can write to the RAM because it's obviously displaying stuff without any corruption. So we know the RAM's good, it can write to the screen. So then I thought the problem might be the CPU reading the data back from the memory, and that's done with some different chips. So let's have a look at that part of the circuit. So if we look back at this chip here, this is the chip for bank 1 that the MPU or the CPU uses to read data from the RAM. Now the fact we've got no screen corruption means that the CPU's been able to write to the RAM, and the video decoders displaying the RAM okay, but I think the CPU isn't being able to read the data back. So this chip here, this buffer chip, is what allows the CPU to read the data back from the actual RAM bus. So let's see what we get on this enable pin here, because there's a chip for each bank, and it's saying there's a problem with bank 1 on the first chip. So let's start with this chip and then we'll work our way back. Right, the game's switched on, so let's have a look at pin 1 here, which is the output enable pin. And I managed to find a little plastic bit for the end of my probe here, so I'm not slipping off the pins. And that looks a bit suspect. All of those random flashing lines there. Let's have a look at one of the other ones, for instance, like this one, which I think is for bank 3. Now we don't have anything on there at the moment, but if I hit the reset button, try and get my probe on there properly. There we go, you can see some nice signals there. I'll just try adjusting the scope a little bit. So we've got some nice signals there, as you can see. But if I go back to pin 1 on this one, you can see we've got all these little spikes. So let's trace back from here and see where that goes. So the enable signal for that RAM chip seems to go to IC 5P pin 3. So 5P, and P is this one here. Now this is the chip that's half desoldered. It looks like somebody's already tried to change this once. So let's have a look. So pin 3 is the output. So let's just go on to pin 3. As you can see, we've got all these spikes still. So the input to this chip is pins 1 and 2, the input of that gate. So pin 1, again we've got loads of those little spikes, and pin 2 we've actually got a signal. So where does pin 1 come from? That comes from chip 4K. So 1, 2, 3, 4, and 4K, and it's driven from pins 12. So let's just see if we can have a look on pin 12. And these other outputs on 11 and 10. So that's pin 10. Let's just reset and see if that changes. Yep, so we've got a signal there. Let's try that pin, and we've got a signal there. And then we've got all of these spikes. You can see there's quite a difference between that and that, for instance. So I think we need one of those chips as well. So I think that's the cause of the RAM problem, and this chip down here is the cause of the CMOS problem. So I'm going to have to order a further 2 chips by the look of it. So we'll fit those once those arrive. And I think I was wrong about those 2 chips, so I'll show you what's going on there. So when I was looking at the schematic, I thought it was going to be either this chip or this one here, because the waveform looked quite spiky on this chip here. So what I've done, I've took those 2 chips and I tried them in my EEPROM programmer, because it's got a function to test logic chips. And that one actually turned out to be okay. That one was a little bit suspect, so I've changed that one. So I thought I'd pull the buffer chip, and I tried that in the EEPROM program, and I'll just show you what it reads on the screen. And as you can see, it's failed the test. There's 2 of the bits are actually stuck on that chip. So I've replaced that chip, I've put it in a socket. I did find a chip for here, for the CMOS settings. I'm still waiting for a new one to arrive, but I did manage to pull one off an old board. So we've got that chip there, we've got that chip there, and I've replaced the buffer chip. So let's see what it does now. Let's power it up. Right, let's switch it on. And we've got the lights as usual, power lights there. Let's go around the front and see what it's doing. Well, hey, initial tests indicate unit okay. Well, that looks good. Yes, it's booted up. Amazing. I've been on with this for so long. Now, unfortunately, we still can't play the game at the moment because I'm still waiting for the PIA chips. But at least it's actually booting up now, and we've actually got the screen on. So the RAM failure, the cause of the RAM failure was that buffer chip that I've replaced, and the 7432. Excellent, right. Hopefully when the PIA chips come, we'll be able to play the game. I've just cleaned all of the leaf switches with some electrical contact cleaner and just a bit of paper there, just by putting it in between, pressing the switch down and then just doing that. You can see all the black that's came off. So hopefully that should sort any problems out with the switches here. Now it has got 2 little light bulbs on the front for the coin entry, which I know are broken. So I think I've got a couple of replacement bulbs, so I think I'll go and fit those. Right, let's switch it on and see if they light up. Oh, one of them does. Well, there's no indicators on the front here, one's just a bit of paper, so you probably have to get some new decals or whatever to go on the front here. But another little job done. Now, one of the things that I've just noticed here is I think there's problems with the PIA chip on the ROM board, because I'm not pressing any of these buttons here, and it's just counting down by itself as if you're pressing the high score button, I think it is. And if I press the button the other way, the up and down, it's increasing, but it's continuously counting. So I think we're going to have a look at the I/O chip on the ROM board. And one of the other things that I've noticed as well, this LED here, LED number 1, seems to be always lit even when you switch it on. So I'll just switch it back off at the moment. And what it should do, once it passes the RAM test, is this LED should flash twice. So we'll just switch it on. And if you notice, that LED is just constantly lit. And that's controlled from the PIA chip here. So I'm fairly sure that that PIA chip's faulty. What we can do, we can have a look at the circuit diagram, because it might go through a couple of other chips first, one to control the LED and possibly an input buffer chip. So let's have a look at that, see if we can just double check to see if it is the PIA chip. So according to the schematic, the high score reset button comes in on pin number 5 of IC24, which is this IC here. So 1, 2, 3, 4, 5. So that pin there, and I'll just try and press the button, and you can see it changing there on the scope. If I press the button down, the signal goes low. If I let go, it goes high. And this is an inverter, so the next pin up should be the output. And if you notice, that's low, and if I press the button in, it goes high. So that chip itself's working fine. So let's have a look at the LEDs, which is IC21, which is this one here, and LED 1, the output is pin number 2 and the input's number 1. So let's go on to pin 2. I don't seem to have anything on pin 2 then. And what have we got on pin 1? Well, we've only got about 1 volt on pin 1, which is the input from the PIA chip. So why have we got 1 volt coming out of the PIA chip all the time? Let's just try resetting it. So I'll go on there and I'll just hit the reset button. And it's still on 1 volt all the time. So I'm pretty sure it's that PIA chip. So when we get a new PIA chip, we'll replace this and hopefully that'll solve the problem. So out of curiosity, I thought I'd try the original 2 ROM chips back in here. And the machine wouldn't boot, it was just doing the rug pattern over and over and over again. Wouldn't get any further. So I think these 2 ROM chips must be faulty, even though they seem to measure okay with the EEPROM programmer. And one of the other things I need to do still is just put some tape over the UV windows on these EEPROMs.
So one of the other little jobs I need to do is to remove this PIA chip here and replace the sockets, because what they've done is they've used 2 smaller IC sockets and they've cut one of them in half. I'll just show you. And I think one of the pins, when I had a look, was kind of not the best. This pin here, you might be able to see it there, because that pin's actually bent. But what they've done is, yeah, they've used 2 sockets. They've used, let's say, like an EEPROM socket there, and then another socket that they've cut the back end off. So I've got a new socket there. So what we'll do is we'll remove this one and we'll fit this one. And then when the new PIA chips come, we'll replace that, and hopefully that'll be the problems sorted on the ROM board. So I'm just going to spin this around like that. So I'll switch the new desolder gun on and then we'll use it to remove this. Let's see if those sockets come out now. I think this one's still held just by those 2 pins there. I'll just try heating those up with that iron. That's one socket out. And that's the other one out. Right, I'll just use a bit solder wick and we'll just clean up these little bits of pads on the top there. Right, at last. I'm just going to do a leg either side here, just to hold it in place. Right, I think that'll do for that. I'm just going to give that a quick clean up with a toothbrush and a bit IPA. Right, I think that'll do for that one. We'll just wait for the new PIA chips to arrive.
I've just finished fitting the new PIA chips and putting the IO board and the ROM board back in after we put the new socket on. So let's switch it on. Oh, and all the lights have gone out. That's a good start. And they both flashed twice. I've just noticed it seems to be making a different noise as well. It's not making the same noise like it was originally. Let's have a look around the front, see what's going on. Well, it seems to be in demo mode. So let's just flick the coin switch here. We've got 6 credits, so I need to adjust that. Let's see if it plays. So I'll hit 1 player. Ah, hold on. when I'm moving down, so the joystick's working the opposite way around. That might just be a wiring fault. Let's just try thrust. That seems weird. I'm sure it's supposed to make a noise when you fire. So that doesn't seem to be working correctly. Actually, it is making a noise, but it doesn't appear to be the right one. Why have we got a constant noise there now? Don't say there's more problems. Don't say there's more problems with this. Yeah, we've got a constant noise coming from the speaker now, a constant sound effect, and that shouldn't be going on. What? I thought we had this fixed. So I need to swap the wire around on the joystick, because that looks like it's wired back to front, and then we need to have a look at the sound card yet. It's like the gift that keeps on giving this thing. I've just flipped the joystick panel over here and I've noticed this blue wire, which is really tight, is the one that needs to go on this side of the joystick, and this one here that's really long needs to come on this side of the joystick. So that's why it's going the opposite way around. So I don't think this has ever worked right from the previous owner. Let's just see if we can solder those. I'm just using the Milwaukee soldering iron that I repaired in a previous video, that one there. So this should be fairly straightforward. Well, that's almost like it's made to go that way. Add a bit more fresh solder to that one. Right, so hopefully that should be that problem sorted out. And I've just noticed there's a date here, manufacturing date, August the 25th, 1981. So looking at the back door here, the sound card, the sounds are selected by this cable here, and that tells it what sound to play. So we've got here pin 1, no connect, pin 2 goes to pin 2, pin 3 goes to pin 3, pin 4 goes to pin 4, etc. And the last pin's not connected, and it looks like pin 8's not used. Now I noticed they've replaced this cable with a different one, so I'm just wondering if that cable is wired up correctly. Let's have a look. So this is the cable here, and if I notice it's far too long in any case. So let's see if pin 1 goes to pin 1. So I'll just unplug it and we'll take it over to the little table I've got over here. It'll be a bit easier to measure with the test meter. Right, so I've just got the meter on continuity. So if we're going to the first pin here, that should go to the first pin here. And we're not getting anything. Let's just try number 2. Nope. Right, so pin 3 goes to the third pin along here. Pin 4, let's try that one, see if that goes to the... Yeah, so this cable, they've got it wired so pin 1 must go to that pin there. Let's just double check that. Yeah, and I bet the last pin goes to the first pin over here. So this cable is actually crisscrossed over. So we could possibly get it working by plugging one of them in upside down, but that's going to look a bit of a mess. So I think I'm going to make a new cable for this, because I've still got some spare plugs. So I'll do that, and then we'll see what happens after I make the new cable up. There we go, just finished making up the cable, and that looks much better, I think. We can probably squash those together a bit more, and yeah, I could put a cable tie around that, and I think that'll look spot on. There we go, just fitted a couple of cable ties, and that looks a lot better. Excellent. Well, there it is, back to its former glory. I've given this screen a clean and adjusted the monitor. I've given the coin door a bit of a clean, and I've also cleaned the control panel here. So let's have a game on it. Right, got a credit on, so let's give it a go. That sounds better, and the thrust sounds about right, and the fire. Excellent, so all the sounds are okay now. Oh, I was never any good at this game. Well, the smart bomb works. Let's try hyperspace. Reverse works. So yeah, so I put a fair bit of hours into this. I think probably all in all about 50 hours time. I searched diagrams and schematics, read up on theory of operation, and ordered parts and everything. So I think this has been one of my more challenging repairs, to be quite honest with you. But we got there in the end. Just in case you're wondering what I replaced on the machine, I've actually lost one of the RAM chips there, but replaced all of the RAM. There was a few logic chips. I think there was another logic chip there, but I can't find it. We had the 2 EEPROMs that I changed, and the 2 PIAs. And then there was just other things like the battery holder, connectors, and a few other bits and bobs like that. And some chip sockets. I thought it might be cool to take an x-ray of all the broken parts here. So this is all of the RAM, and the top row here are the ones that are in ceramic packages. And these ones here are the ones that are in plastic. These are the 2 PIA chips here, which both seem slightly different if you look. This one's got like a V pattern at each end, and this one's just got a straight line through. These are the failed logic chips, and those are the 2 EEPROMs, ROM 7 and 10. I just thought you might find that a little bit interesting. So here's a little bit bonus footage. I thought I'd get some of the machine all nicely lit up there, with a nice banner at the top all lit up. You can see the screen a little bit better there now as well. So I'm really pleased with this one. It came out really well. I think we ended up doing a good job on this one. What do you think? Let me know in the comments below.